Hello viewers. So in this session I am going to explain you about the third application of dimensional analysis. Okay, in our last session we will discuss about two applications and we have solved numericals on that. Fine then. So here the third application of dimensional analysis is to derive a relation between different physical quantities. So here, by using the concept of dimensions, by using the dimensional analysis, we are going to derive a relation. For example, if I don't know the equation of centripetal force, or if I don't know the equation of time period, then with the help of dimensional analysis I can easily get that equation. Okay, so let me tell you today how we are going to get a particular equation. Okay, how we are going to derive a particular equation, okay, which depends upon physical quantities. So here, to derive a relation between different physical quantities, so we should have to follow the principle of homogeneity. So in my last session also I have told you about the principle of homogeneity, right? So here homogeneity principle ಏನು ಹೇಳುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಒಂದು equation dimensionally correct ಇದೆಯೋ ಇಲ್ವೋ ಅಂತ ಯಾವಾಗ ಹೇಳ್ತೀವಿ ನಾವು, when the dimensions of the left hand side is equals to the dimensions of right hand side. That means the dimensions of the equation occurring on both the terms are equal or the same ಅಂತ ಹೇಳ್ಬೋದು ಅಲ್ವಾ. ಸಪೋಸ್ ಡೈಮೆನ್ಷನ್ಸ್ ಆಫ್ ದ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಸೇಮ್ ಇದ್ದರೆ ಅವಾಗ ನಾವು ಆ ಈಕ್ವೇಷನ್ಸ್ನ ಆ ಟರ್ಮ್ಸನ್ನ ಏನು ಮಾಡ್ಬೋದು ಅಂತ ಹೇಳಿದ್ರೆ ಕಂಪೇರ್ ಮಾಡ್ಬೋದು, ಆ್ಯಡ್ ಮಾಡ್ಬೋದು ಅಥವಾ ಸಬ್ಟ್ರ್ಯಾಕ್ಟ್ ಮಾಡ್ಬೋದು ಅಂತಲೂ ಕೂಡ ನಾನು ನಿಮಗೆ ತಿಳಿಸಿದ್ದೀನಿ ಅಲ್ವಾ. ಸಿ ಹಿಯರ್, to derive a relation between different physical quantities. So how we are going to derive? Suppose if you have a question like this, okay, derive a relation of, or derive a relation for centripetal force, derive a relation for centripetal force acting on a particle, centripetal force which is acting on a particle of mass m moving with a velocity v, okay, in a circle of radius r. So this is my question now. So here I have to derive the expression for centripetal force which is acting on a particle of mass m and it is moving with a velocity v in a circle of radius r. Okay, so for that, to understand it in a better way, I have to consider a circle here. So this circle is having a center O, okay, and think that you are having a particular particle P. Okay, so the position of the particle is at P here. So the distance between O and P is R, which represents the radius. Okay, radius R. And this P, if it is moving in a circular path, okay, so the velocity for the particular particle will be v here. ಒಂದು ಪಾರ್ಟಿಕಲ್ ಒಂದು ಸರ್ಕ್ಯುಲರ್ ಪಾತಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅದಕ್ಕೆ ವೆಲಾಸಿಟಿ ಅನ್ನೋದು ಬರುತ್ತೆ. ಸೊ ವೆಲಾಸಿಟಿ ಎಷ್ಟಿರುತ್ತೆ? ವೆಲಾಸಿಟಿ ಇಸ್ v ಆ್ಯಂಡ್ ಆ ಪಾರ್ಟಿಕಲಿಗೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಮಾಸ್ ಎಷ್ಟಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಸ್ಮಾಲ್ m ಇದೆ, ಆಯಿತಾ. So if a particle is moving in a circular path, so ಅಲ್ಲಿ ಒಂದು centripetal force generate ಆಗುತ್ತೆ. So centripetal force ಯಾವಾಗ exist ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ when a particle is moving along a circular path. So force direction ಯಾವ ಕಡೆ ಇರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ force is always acting towards the center, ಆಯ್ತಾ. So we are having two types of forces here, okay, when a particle is moving in a circular path. So one is centripetal force and another one is centrifugal force. So centrifugal ಯಾವಾಗ ಬರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ when a stone is whirled in a circular path, then force will acting in a outward direction. Force direction ಯಾವ ಕಡೆ ಇರುತ್ತೆ? outward ಇರುತ್ತೆ. Force direction suppose towards the center ಇದ್ರೆ ಅದನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ? that is our centripetal force. Okay, so here we have to calculate, so here we have to derive an expression for centripetal force with the help of dimensional analysis. Okay, then so first let me write the expression for force. Okay, so before that, so ಏನು given data ಕೊಟ್ಟಿದ್ದಾನೋ ಸೊ ಅದರ ಮೇಲೆ ನಾನು ಯಾವ ಥರ ಬರಿಬೋದು ನೋಡಿ. ಸೊ ಆಬ್ವಿಯಸ್ಲಿ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಯಾವುದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ, ಮಾಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ, ವೆಲಾಸಿಟಿ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ, ಆ್ಯಂಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ ರೇಡಿಯಸ್ ಆಫ್ ಅ ಸರ್ಕಲ್. ಸೊ ಹಿಯರ್ ಫಾರ್ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ವಿಲ್ ರೈಟ್ F suffix C ಅಂತ ಬರಿತೀನಿ. ಫಾರ್ ಮೈ ಕನ್ವೀನಿಯನ್ಸ್ ಐ ಆಮ್ ರೈಟಿಂಗ್ ದಿಸ್ F suffix C, ಸೊ ವಿಚ್ ಇಸ್ ಪ್ರಪೋರ್ಷನಲ್ ಟು. ಓಕೆ, ಸೊ ಯಾವುದಕ್ಕೆ ಪ್ರಪೋರ್ಷನಲ್ ಆಗಿದೆ, ಮಾಸಿಗೆ ಪ್ರಪೋರ್ಷನಲ್ ಆಗಿದೆ, and it is proportional to velocity and as well as it is proportional to radius. Okay, so here dimensions are nothing but powers, so I have to represent this with powers. So let me represent the power of mass by A and power of V by B, and the power of my third term is C. So elladu kuda different physical quantities. Nodi, mass one physical quantity agidre, velocity is another physical quantity, whereas radius is nothing but length is another physical quantity here. So idike dimensions kuda A, B, C dimensions enirutte different agirutte. So FC is proportional to m raised to A, V raised to B, R raised to C anta barita idini. ಆಯ್ತಾ? ಸೊ ಹಿಯರ್ FC, if I remove the proportionality, we'll get some constant quantity here. So let me write that constant is K ಅಂತ ಬರುತ್ತೇನೆ. So K into m raised to A, V raised to B, R raised to C. Okay, so what is this K? It is a constant. So ಈ K ನಾನು 1 ಅಂತ ತಗೊಳ್ತೇನೆ. I don't know the value of K here, so K is equals to 1. Okay, because force is only depending upon mass, velocity and radius. So here I am getting a constant K. Okay, for my convenience we'll put K is equals to 1. So therefore FC is equals to m raised to A, V raised to B, R raised to C anta barutte. So let me consider this is my equation 1 anta tagoltene. Okay, so this is my first equation I got now. Okay, so now I have to make use of the dimensional analysis. So dimensional analysis inda nanu ee force na expression find ಮಾಡಬೇಕು. Okay, one thing I knew here is centripetal force is proportional to m, V and R, but I don't know what is the actual expression for centripetal force. That I have to find here by the help of dimensional analysis. Okay then, so but I know the dimensional formula for force alva. Force dimensional formula gottu, mass dimensional formula gottu, velocity gottu, radius is nothing but length dimensional formula gottu. So therefore I am going to write, so for the dimensional formula of force, F suffix C. Okay, so here we'll directly write the dimensional formula because I'm not having much space here to write. Okay, so the dimensional formula of force is m raised to 1, L raised to 1, T raised to minus 2. So this is the dimensional formula of force we have. So this is equals to, okay, what is the dimension of m? M represents mass, so dimension of m is capital M, small m is dimension formula of mass is capital M, which is raised to A. So here I have to write A, and the dimensional formula for velocity, V represents velocity here, so velocity dimensions enu LT minus 1. So LT minus 1 raised to B there, so it raised to B anta baritira. And the dimensional formula for radius is nothing but length, so length ige dimensional formula enu capital L, which is raised to C. So here I have to write L power C. Okay, so according to the principle of homogeneity, we know that the powers can be added, subtracted or compared here. So ನಾವು ಇದನ್ನ ಕಂಪೇರ್ ಕೂಡ ಮಾಡ್ಬೋದು ಈ ಈಕ್ವೇಷನ್ಸ್ನ, ಆಸ್ ವೆಲ್ ಆಸ್ ಇದನ್ನ ಆ್ಯಡ್ ಕೂಡ ಮಾಡ್ಬೋದು ಅಥವಾ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಬೋದು. ಸೊ ಇಲ್ಲಿ ವೆನ್ ದ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಆಫ್ ದ ಈಕ್ವೇಷನ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ದ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್, ದೆನ್ ಐ ಕ್ಯಾನ್ ಈಸಿಲಿ ಕಂಪೇರ್ ದ ಈಕ್ವೇಷನ್ಸ್. ಸೊ ಇಲ್ಲಿ ನೋಡಿ, ಈಗ ಇದನ್ನು ಇನ್ನೂ ನಾನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತೀನಿ ಇದನ್ನು, ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಎಲ್ ರೈಸ್ ಟು ಬಿ ಇದೆ, ಎಲ್ ರೈಸ್ ಟು ಸಿ ಇದೆ. ಸೊ ಇದನ್ನು ನಾನು ಆ್ಯಡ್ ಮಾಡ್ಕೋಬೋದು, ಪವರ್ಸನ್ನು ಆ್ಯಡ್ ಮಾಡ್ಕೋಬೋದು. ಸೊ ದಿಸ್ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ ಎಮ್ ರೈಸ್ ಟು A, L raised to, okay, L raised to B and L raised to C, L raised to B into L raised to C. So I can add the powers here, L raised to B plus C into T raised to minus 1 into b is minus b here. So this is equals to m raised to 1, l raised to 1, t raised to minus 2. Okay. So now I can easily compare. So mass inna mass jote compare ಮಾಡ್ತೀನಿ, length inna length jote and time inna time jote compare ಮಾಡಿದ್ರೆ ನನಗೆ ಏನು ಬರುತ್ತೆ ನೋಡಿ. Okay, so let me divide this with the three components here. So ಇಲ್ಲಿ m inna compare ಮಾಡಿದ್ರೆ ನಾನು ಈ mass ಜೊತೆ compare ಮಾಡಿದ್ರೆ a is equals to ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ a is equals to 1 ಅಂತ ಬರೀಬಹುದು. length ಜೊತೆ compare ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ ನೋಡಿ b plus c is equals to 1 ಅಂತ ಬರೀಬಹುದು. ಅದೇ ಇಲ್ಲಿ see here I'm going to find the values of a, b and c. ಯಾಕಂತ ಹೇಳಿದ್ರೆ fc is proportional to m raised to a, v raised to b, r raised to c. f ಯಾವುದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ ಅಂತ ನಮಗೆ ಗೊತ್ತಿದೆ, m, v, r ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ, ಬಟ್ ಐ ಡೋಂಟ್ ನೋ ದ ಡೈಮೆನ್ಷನ್ಸ್, ಐ ಡೋಂಟ್ ನೋ ದ ಪವರ್ಸ್ ಹಿಯರ್. ಸೊ a, b, c ಗೊತ್ತಿಲ್ಲ ನನಗೆ. ಆ a, b, c ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ವಿಲ್ ಗೆಟ್ ದ ಫಾರ್ಮುಲಾ. ಸೊ ಐ ಆಮ್ ಫೈಂಡಿಂಗ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ a, b, c there. Okay, then minus b is equals to minus 2. Minus b is equals to minus 2 ಆದರೆ b is equals to minus 2 ಆಗುತ್ತೆ. That means minus minus gets cancelled there and b value ಏನು ಬರುತ್ತೆ plus 2 ಅಂತ ಬರುತ್ತೆ. So now I am going to substitute b is equals to 2 to get the value of c here. So 2 plus c is equals to 1, therefore c is equals to minus 2 plus 1, that is minus 1. So minus 1. So I got the values of a, b and c here. A is equals to 1, b is equals to 2 and c is equals to minus 1 anta bartade. Okay, so here I am going to write, hope you don't mind. Okay, see, now I have to substitute the values of a, b and c in my equation 1. Okay, so we'll write it here, substituting the values of a, b and c in equation 1, in my equation 1. So therefore equation 1 implies fc is equals to m raised to a, v raised to b and r raised to c. This is my centripetal force expression. So this is equals to m raised to a is equals to how much 1, v raised to b is equals to 2 and r raised to c is equals to minus 1. Okay, so this can be written as m raised to 1 is m itself, v square r raised to minus 1 ನಾನು ಕೆಳಗಡೆ ತಗೊಂಡ್ಬಂದ್ರೆ 1 by r ಅಂತ ಆಗುತ್ತೆ. So therefore fc is equals to mv square divided by r. So this is the expression for centripetal force. Centripetal force expression mv square divided by r. So this is how we can easily get the equations of a particular physical quantities with the help of dimensional analysis. Clear? Okay, let's move on to another physical quantity. So I'm going to consider one more physical quantity here, so that I'm going to find, or I'm going to derive a formula for time period here. Okay, so so this is my second problem, second numerical in the third applications of dimensional analysis we have. So here derive a relation of or derive a relation for time period, derive a relation for time period, okay, which depends upon length, okay, mass and acceleration due to gravity. gravity. Okay, so here you have to derive the relation for time period, so which depends upon mass, length and acceleration due to gravity. So here first let me write time period. Time period, it is proportional to ಯಾವುದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ, mass, length and acceleration due to gravity ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ. So for mass I am going to write small m, and for length, which is represented by small l, and acceleration due to gravity, as you know, it is represented by small g. Okay then, so here we'll write this as m raised to a, l raised to b and g raised to c. So time period is proportional to m raised to a, l raised to b and g raised to c. If I remove the proportionality, we'll get some constant quantity here, that is k. So k into m raised to a, l raised to b and g raised to c. So let me consider this as equation number 1. Okay, so time period is usually represented by capital T. So here we'll write capital T, hope you don't mind, for time period. Okay, T is equals to this equation. Okay, now I have to find the values of A, B and C. So to find the values of A, B, C, I should have to write the dimensions of left hand side, and then I have to write the dimensions of right hand side. After that I have to compare, right? Compare the equation, okay, to get the values of A, B and C here. Okay then, so what is the dimension of time period? So time period dimensions yav tara baritira, m raised to 0, l raised to 0, t raised to 1. So this is the dimensional formula for time period. Okay, so this is equals to k into, okay, so here m raised to, what is the dimensions of m? Capital M, m raised to a, dimensions of l, that is length, l raised to b, and the dimensions of acceleration due to gravity is l t minus 2, which is raised to c. Okay, so this implies k into m raised to a, c, l into l raised to c, l raised to b, l raised to c, which can be written as l raised to b plus c. So ನಿಮಗೆ ಗೊತ್ತಿದೆಯಾ, l raised to b into l raised to c ಈ ಥರ ಏನಾದರೂ ಇದ್ದರೆ ನಾವು ಪವರ್ಸನ್ನ ಏನು ಮಾಡ್ಬೋದು, ಆ್ಯಡ್ ಮಾಡ್ಬೋದು. ಸೊ ಅದನ್ನು ನಾನು ಇದನ್ನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ l raised to b plus c and t raised to minus 2 into c is minus 2c, minus 2c. So therefore m raised to 0, l raised to 0, t raised to 1 is equals to, t raised to 1 is equals to m raised to a, okay, m raised to k into m raised to a, l, b raised to l raised to b plus c and t raised to minus 2c. Now I can easily compare and we can easily find the values of A, B plus C, sorry, A, B and C here. So only we have to compare. So mass inna mass jote compare ಮಾಡ್ತೀರಾ. A is equals to 0 ಆಗುತ್ತೆ, B plus C is equals to 0 and minus 2C is equals to 1 here. So therefore A is equals to 0, B plus, okay, B plus C is equals to how much? B plus C is equals to 0 and minus 2C is equals to 1. Clear? Okay, so here minus 2C is equals to 1 adre, C is equals to, it becomes minus half. So therefore we'll substitute the values of C is equals to minus half to get the value of B. So B minus half is equals to 0 or B is equals to minus half akade hodre it becomes plus half. So these are the values of A, B and C. Okay, so my next thing is I have to substitute the values of A, B and C in my equation 1. Okay, so equation 1 implies T is equals to K into M raised to, okay, so we'll write the equation 1 here. Okay, after that I am going to substitute the values of A, B and C. So this is my equation 1. Therefore T is equals to K into M raised to, K value is 0, L raised to B value is half and C value is minus half. Okay, so therefore T is equals to K into anything to the power 0 represents what? 1. Anything to the power 0 is equals to 1. Okay, L raised to half, and here you are having G raised to minus half, so adana nan kelagade tagondre it becomes G raised to plus half. Okay, so L raised to half is nothing but what? Square root of L. So therefore it can be written as, okay, where I have to write K into square root of L by G. So this is the expression for time period. So here we'll write T is equals to K into square root of L by G. So what is the actual formula to calculate the time period anta helidre? T is equals to 2 pi into root of L by G anta agutte, but a constant K is equals to 2 pi. So just you have to derive up to here. Okay, T is equals to K. K is nothing but a constant. That constant value is 2 pi, we know, but ನಿಮಗೆ ಗೊತ್ತಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ just ಇಷ್ಟು ಬರೆದರೂ ಕೂಡ ನಡೆಯುತ್ತೆ. T is equals to K into root of L by G. So this is the actual expression for time period, so which we got from the dimensional analysis. So by using the third application of dimensional analysis, we can derive a relation between different physical quantities. Okay, so ಯಾವುದಾದ್ರೂ ನಿಮಗೆ physical quantity ಗೊತ್ತಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ, so ಈ ಮೆಥಡನ್ನು ಫಾಲೋ ಮಾಡಿಕೊಂಡು ನಾವು ಯಾವುದು ಬೇಕಾದರೂ physical quantityನ obtain ಮಾಡ್ಬೋದು. Is this clear for you? Okay, hope you understood this concept. Okay, and from my next session I am going to solve the numericals on units and dimensions. Okay, till then take care all of you.